Hello, welcome to part 4 on underground excavations in rocks for tunneling and mining. I will first give a general introduction to underground excavations in civil and mining engineering. In later sessions, we will learn rock tunnel excavation, rock reinforcement and support, and the different mining methods. When we talk about underground excavation, there are a number of key topics. First, we need to know the types of underground excavations, whether it is a tunnel, a cavern, or a shaft, or a specific type of mine. Then there are a variety of excavation methods by different machines and techniques. The major categories of excavation methods are mechanized excavation, blasting, and controlled caving. Design rock support method is perhaps the most important part of underground excavation. The common techniques are rock reinforcement, rock support, and ground improvement. Underground development also has lifespan, which influences excavation and support. As tunnels and underground mines are excavated in rocks, the role of rock mechanics is inevitable. Rock strength and deformability, hardness and abrasivity, rock mass quality, in-situ stress, and groundwater, all those rock mechanics parameters have governing effects on the design and implementation of tunnels and underground mines in rocks. In general, a tunnel is a long, linear underground opening built for transport and utilities. It is a permanent structure built for long service life. We commonly see tunnels for trains and metros, for roads and highways, for canal and waterway, for water transfer, and for sewage transfer. There are also tunnels in mines, serving as mine access and for ore transport. Digging tunnels and caves is perhaps the very first engineering by human, seeking sheltering and protection. However, modern rock tunneling perhaps starts with the construction of the tunnel for Canal du Midi, built in 1681. It was the first one to use explosives for rock excavation. Other rock tunnels made in history are, for example, the Simplon Tunnel built in 1906 by the Swiss to cross the Alps with almost 20 kilometers length, being the longest tunnel for about 80 years. The English-French Channel Tunnel, built in 1994, has the longest undersea tunnel of 39 kilometers. And the Godard Base Tunnel, again by the Swiss to battle with the Alps, is the longest railway tunnel of 57 kilometers, with maximum overburden of 2.4 kilometers. The tunnels are shown in the photo here. Water diversion tunnels in northwest China has a length exceeding 200 kilometers. Rock caverns are large span openings excavated in rocks. They are basically man-made caves. They are built on their own or built as part of tunnel system. On their own, rock caverns are built for storage of oil and gas, for warehousing and the storage of various goods and products, and as laboratory for hazard waste. Caverns are also being used for sports facilities, libraries, museums, car parks, and also used for wastewater treatment plants. The cavern in the photo is for storage and is 30 meters wide, 100 meters long, and about 21 meters high. In hydropower station, caverns are built for powerhouse and plant. We also build caverns as a part of metro tunnels to host the metro stations. In long-term railway tunnels, there are caverns for rail crossing. In room and pillar mining, the excavated rooms are in fact caverns. One good example is in Kansas. All the round pillar limestone mines are now refurbished caverns for use as storage, logistic hubs, and offices. To build tunnels, caverns, and mines underground, we will need access, which is by building shafts. Shafts are vertical and inclined openings to provide connections between the surface to the underground, or between different depths underground. Shafts can be permanent structures or for temporary use. Permanent shafts can be for permanent access, ventilation, mechanical and electrical installations. Temporary shafts are, for example, construction access in cavern construction. In mining, temporary shafts are excavated for ore movement and haulage. The photo here shows a made shaft with access to service tunnel. The shaft continues down to the main cavern construction tunnel. Underground excavation in mining is primarily to extract minerals. By doing that, all rocks and the coals are excavated and transported to the ground for processing. To support the mining process, shafts and tunnels are built that are similar to what we just have mentioned. Although the lifespan may be shorter, just to cover the duration of mining operation. Mine excavation can be supported and caved. Supported mines are that after mining, the mined void does not collapse and is supported by itself, which is naturally supported, or it is supported by the backfill or the broken ores left in the mine. Then it is artificially supported. Room and pillar mines are the best known naturally supported mines, and is illustrated in the drawing on the right. Those mines are standing without collapse for hundreds of years, and you can visit many of them around the world, and some of them are world heritages. We will learn more on those mining methods, including room and pillar and open stoping as naturally supported mine, cut and fill stoping, and shrinking stoping as artificially supported mining. Caving mining, on the other hand, allows mined void to collapse and the rock above to cave into the mine. Longwall mining is perhaps the most common method today for coal mining. You can see the caving behind the extraction. Longwall mining and sublevel caving in the process of ore and coal extraction and removing, the mine space is allowed to collapse and cave. For block caving, all rocks with natural fractures progressively collapse on its own weight and is flowed down through jaw points and is removed and transported. The caving process is controlled and is usually initiated by undercutting blasting. Again, we will learn those mining methods and associated rock engineering in later sessions. We have learned rock excavation methods earlier in rock slopes. The principal techniques of rock excavation are the same, by blasting and by machine. For tunneling today, mechanized excavation using TBM counts perhaps around 70 to 80% of the rock tunneling in terms of length, particularly for long tunnels. Mechanized excavation uses powerful cutting machines and cutting tools developed for rock tunneling and shaft excavation. TBM cuts all types of rocks by roller cutters in full face and a circular section. You can see the TBM on the top photo and roller cutters on the cut head on the red and the blue bands. Mobile machines are generally for soft and medium rocks. The middle photo shows a roller header. The lower photo is a mobile machine for hard rock cutting. Longwall coal mining is extensively mechanized, and the machine is on the last slide. We will learn more on mechanized underground rock excavation in a later session. Blast using explosives is still the most effective method to break and excavate hard rocks. It involves drill holes into the rock and put explosives in and blast away the rocks. Drill and blast method is a cyclic excavation process. The typical drill and blast excavation cycle is illustrated on the right. Excavation by blasting is flexible in terms of tunnel shapes, dimensions, and the layout. Blast is also used for hard rock mining. In block caving mining, we utilize controlled rock mass collapsing under gravity to remove all rocks. For tunnels and caverns, our effort is to maintain the stability of the opening through shape optimization, rock reinforcement and support. This is what we are doing for rock caverns, shown on the left. As shown by the right drawing, caving mining is the opposite. It is to optimize caving potential or capability of the rock mass to ensure roof collapse or fail to happen as the mean of all production. In fact, as we will see later, both stability and capability are governed by rock mass quality, and both are assessed by IMR and the Q rock mass classifications. Capability can perhaps be viewed as limit of stability of unsupported rock cavern. Although we often use the term of underground rock excavation for tunnels in the mine development, actually, underground development, particularly underground construction, maintaining stability of the excavated opening is often more important in engineering. Rock tunnels and cavern stability are generally maintained through rock reinforcement and rock support. For competent and reasonably good rock mass, rock material strength is generally higher than concrete. Failures of rock tunnels and caverns are mainly due to the joints and the fractures in the rock mass. Therefore, rock reinforcement is aiming to improve the rock mass to become continuous or to have higher resistance of the joints and the fractures by using steel bolts and the cables to tie the rock blocks together, as shown here, or by using shotcrete and the grouting to seal the joints, or by dewatering. Rock support, on the other hand, is to apply reactive force to the opening in order to limit the deformation and to prevent failure through external structures and elements installed against the roof and the walls. The common structures for rock supporting in tunnels and mines are pillars and the lining, using concrete, steel, and the timber, such as steel sets, steel wire mesh, and the concrete lining. Prefabricated segmental concrete lining is a standard supporting structure for tunnels excavated by shield tunneling boring machine, as shown by the photo on the right. In general, tunnels, caverns, and shafts constructed for infrastructure use are considered to be permanent structures to last. Usually, their designed lifespan is at least 100 years. In fact, tunnels built more than 100 years ago are still in operation. The 19.8 kilometer long Simplon Tunnel, shown on the right, was built in 1906 and was the world's longest railway tunnel until 1982. After over 100 years, it is still in operation. I traveled quite frequently in this tunnel when I was working at EPFL in Lausanne. Tunnels and shafts for mines may have a shorter designed lifespan, need to last only for the mining operation. Lifespan has implications on the excavation and the support of underground structures. For underground structures and the development in rocks, rock mechanics and rock engineering is applied in every aspect and every stage of underground excavation. As illustrated by the design of a liquefied petroleum gas storage cavern complex on the right, we will need to design of underground layout and the geometry in terms of depth, separation, and the size, to select rock excavation methods and the machines, to adopt rock reinforcement and support, to manage risks associated with and the hazard induced by underground excavations, and to consider the environmental effects and sustainability. In longwall and caving mining, we will need to control the collapse and the caving, the rock masses. All those aspects require input of rock mass quality and the rock mass behavior during excavation, applying rock mechanics principles to deliver best rock engineering practice. The table here is an example of how tunnel design can be influenced by rock properties for different types of tunnel usages. For example, for highway tunnels, due to relative flexibility in layout and geometry, we need to choose and design tunnel and portal locations, tunnel span, length and grade, excavation method, support requirement based on rock mass profile and properties, rock material abrasivity, groundwater, and in-situ stress conditions. For metro tunnels in urban area, the biggest concern is on ground settlement. Therefore, based on ground conditions, specifically rock mass quality and groundwater, we need to select appropriate excavation methods and the TBM type to design support and the ground improvement in order to control ground settlement. Another interesting example is oil storage cavern in rocks. We will need to ensure there is sufficient groundwater confinement around cavern to prevent oil leakage, and at the same time controlling groundwater inflow. Therefore, designing and excavating water curtain tunnels above the caverns depends on rock mass permeability, joint connectivity, and groundwater condition. This is the end of this introductory session on tunnels and underground mines. We will go through in details on excavation techniques, failure analysis, various support design methods, and different mining methods in the coming sessions. See you later, and bye now.